Hello guys, Cristiano here. I am a C programmer, learning all those things that I can. Hit the subscribe button, let a comment, that'll help so much the channel. All my videos will be in a fast mode with explanation. I'll reduce the time to be more precise. And we will face a lot of mistakes and debugs. Everything's calculated, or not. So don't be afraid. The link for all the source codes will be in the description. If you wanna follow, just get your copy. In this video, you are bringing the Postgres, building on our existing MySQL implementation. Adding Postgres support should be a relatively straightforward process, since we both interact with databases in a similar way. We can leverage MySQL codebase as a model for Postgres. This reusability will significantly streamline the implementation process. Let's get started by integrating Postgres in our toolbox. We begin our journey by following a similar path. First, we create the header, the source file, and the CMake lists text file. These foundational steps set the stage for our work with Postgres. Our next task is to adjust the CMake list text to incorporate the necessary Postgres information, ensuring our build system is aware of this new dependency. If the feature is enabled, we proceed by adding the relevant files. At this point, we also consider creating a list to include a small step that promises to be beneficial down the line. With our dependencies and includes in place, we move it to main CMake lists, where we incorporate the Postgres dependency. We also introduce an option to enable this feature, keeping it off by default and maintain flexibility. To streamline our work, we use the MySQL content as a foundation for Postgres, copying it over to begin our modifications. Our adjustments start with the header, where we add the necessary variables to work with Postgres. Since the function shares similarities, we simply rename all instances of MySQL to Postgres. Next, we turn our attention to the source file, making similar adjustments. We update the key points, such as headers, ensuring all references to MySQL are replaced with Postgres. In the initialization function, so we move on to the open function. In the execute function, we adapt it to use the Postgres exec function. We test for successful execution and set the result to true if it passes. In the result set function, our first task is to verify the validity of the result. We then retrieve the number of rows and columns to allocate memory to read each record. We iterate over each row, retrieving the fields and populating our object. Admittedly, better name could have been chosen for the indexes, but we will press on, passing the object to the user interface for processing. Finally, we release the allocated resources and clear the result, wrapping up our modifications. Our journey continues as we adjust the close function to ensure the result is cleared before closing the connection. In the argsIsValid function, no changes are necessary. Moving on to the connect function, we create the connection string. We use the provided connection information to format this string. Establishing a connection to the database. We test the connection, and if successful, we set the flag to true. We employ a similar approach for testing, using MySQL as our base. This requires a test database. We modify the Docker Compose configuration to include Postgres and adjust to schema accordingly. In the test CMake list, we add Postgres and rename all functions from MySQL to Postgres. Additionally, we change the connection port and the IP address. Everything else remains the same. We enable set Postgres, but initially we forget to set it on. Once enabled, we encounter several errors that need adjustment. First, we correct the mistake in the site includes list. Next, we tackle problems related to typos, making the necessary corrections. However, we notice the test hasn't compiled. We realize we fell victim to infamous copy and paste error, forgetting to change the variable to Postgres. After making the proper changes, the code compiles without errors. But the test still fails due to the incorrect database schema syntax, as revealed in the container log. On the third, we rebuild the test from the beginning. Finally, with all issues resolved, the test passes successfully. Although we still encounter connection issues at this stage, this will be resolved in due course. With Postgres now integrated in our toolbox, it's ready for use. That's all for now. I appreciate it if you get here. Don't you forget to hit the subscribe button, leave a comment and share. Knowledge is not enough. Waiting for more. Bye. See you soon.